We now move to the second part, which is the writing part for the grade 10 elite. The question 16 is to solve exponential equations and inequalities. The first question is about investment. Monique wants to invest 4,000 in a savings account that pays 3.4% annual interest compounded continuously. Yeah, this is very important. Compounded continuously means exponential is involved. Now the formula over here is given A equals P, that is the initial amount, e to the power RT. Even if you don't get this formula in the question, please remember it. Now here I'll just tell you what each term means. That's what is explained. A is the amount after certain time t, whereas P is the initial amount and E is Euler's number E, R is the rate of interest. Now, whenever it's being compounded continuously, we take E, that is 2.71. It's a constant number. And the first question over here, what is the balance of Monique's account after 5 years? They have given all the details. See, this is P, this is R, and the time is also given. So just substitute what is the amount after 5 years. That would be 4,000 multiplied by E to the power R is 3.4%. You can write it as percent directly in calculator, and time is 5. That will be the answer. Just put it in the calculator and that will be the answer. We will do it in a while. Now let's go to the second one and write the equations. Monique wants to wait until there is at least $6,000 in account before withdrawing any money. How long must she keep money in the savings account? Now it's about time. How long? That's the time, right? So let's see over here. A, P e to the power RT, but it's about inequality. At least is used. Now we need to find the time where the money exceeds $6,000. So this amount must be, whatever we find must be greater than or equal to 6,000. So 6,000 must be having the lower sign. So here we have 6,000 less than or equal to, initial amount is 4,000 times e to the power r is the same thing, 3.4, but we don't know, okay, it's percent, we don't know the time t. So now what you can do is just divide both the sides by 4,000 and take off this coefficient before e. So it'll be over here 6,000 by 4, 6 divided by 4 is 1.5, will be less than or equal to e to the power 3.4% t. Now to solve exponentials, all you need to do is take natural logarithm on both the sides, ln over here and ln over here, e to the power 3.4% t. What happens is they are inverse, right? Natural logarithm and exponential. So basically you will have ln 1.5 less than or equal to 3.4% t. So to find t, now I'll just write in the same order because there's inequality. Just do ln 1.5 divided by 3.4%. That will be less than or equal to t. That's your answer. The last question over here is, suppose Monique wants to have at least $10,000 in account. Okay. Now again it's 10,000 at least. After 10 years, the time is given and the rate of interest is same. What is the principal amount? The initial amount, how much she should invest in order to have 10,000. This is 3.4% and time is 10 years. So after 10 years, she wants to have 10,000 in her account for this rate of interest. How much should she invest? Just divide both the sides by e to the power 3.4% into 10. You will get the answer. That should be less than or equal to p. So this cancels off. So that would be the answer. Now over here, you're dividing both the sides and whatever you get the answer over here is p. Okay, let's do it in the calculators now. So I've typed this equation as it is. 4,000 times exponential is by shift and ln over here. 3.4% is by shift and this opening bracket symbol above it is percent into 5. The answer is 4,741. Let's just check the answer. Yes, that's the correct answer. Let's round it out to 2 decimal after the 2 digits after the decimal, so it's 2. And the second one, we have it over here. It will be natural logarithm ln 1.5 divided by 3.4%. Sorry, it's percent. That's over here. And the answer is 11.93, you can say. Yes, that's correct. 11.93 is less than or equal to t. And lastly, we have over here, it's 10,000 divided by e to the power 3.4%. That's over here, multiplied by 10 years. The answer is 7017.7. That's the answers. If you know how to write the formula and substitute, very simple. Now here it's the same thing. I'll just walk through the answers. Now here the depositing amount is $750 and the rate of interest is 2.7. Formula is given. We need to find after 3 years. So just substitute over here 750. 2.7 in percent. So it will be divided by 100. So it's 0.027. If you write it in percent, it's 2.7. Multiplied by the time 3. Put it in the calculator. You'll get the answer. Here for the next one, how long will it take for the balance to reach at least 2000? Same thing we had a while ago. We have to write 2000 less than or equal to 750 and solve it up. Over here, once you remove the coefficient of e, you should take ln on both the sides. It's called ln or ln, natural logarithm on both the sides, and then you'll get the answer. Now the last one is, she wants to earn at least $1,000 after 5 years, and the compound rate of interest is same. So how much money should she invest initially? The p value is unknown. Divide over here by this term, both the sides, and you will get the answer 873.72. So that's how we solve that problem. Now let's look at a population growth problem. Here also they have given you the formula and they are telling you A naught is the population at time t0, which is the initial population. R is the annual growth rate. The world's population at the beginning of 2008 was estimated to be 6.64641 billions. Okay, it's this much is millions, then comes billions. If the annual growth rate is 1.2%, when will the world population reach 9 billion? So now let's write the equation. A is known to be 9 billion. I'll write in terms of billions. 9 is equal to 6.641 billion. And then e to the power r is 1.2%. And the time is what we are solving for, t. Now divide everything by 6.41 billion. You will get 9 divided by 6.641 equals e to the power 1.2% t. Take natural logarithm on both the sides. It will be ln 9 by 6.641 over here equals ln e to the power 1.2% times time. And then this and this cancels. You're remaining with only this. This will be equal to 1.2% time. So you can just divide everything by 1.2%. Over here also 1.2%. And what you get is whatever the answer will be equal to t. So we'll just put in the calculator. I've typed everything in the calculator and now we get 25.33 years, that is 25.33. This is the time. But here they're asking when exactly, which year will the world population reach 9 billion, isn't it? We know 2008 was the initial population. So we need to add 25 years to 2008 plus 25.33 years. 25 plus 8 is 33. So 2033.33. In 2033, it is estimated that we'll reach 9 billion. But as of now, it's 8.1 billion already. It might reach much earlier. But this is the estimated population based on old data. So that's how we solve this. And you can see, okay, they have taken it as 25, but we got 25.33. That's fine. On average, it's 2033. So that's the thing. And again, another similar one which we have done before about investment. So I'll just walk you through this. Here they have told Jamie's bank pays 2.8 annual interest compounded continuously on a savings account. She invested 2,000 in the account. Using the formula over here given, determine how long will it take for the initial deposit to double its value. The only thing is, here they have given you the principal amount P, R is given, Time is unknown. They're asking what time will it take for this money, whatever she invested, will be doubled two times. So you have to just write 2 times 2000. If you write the amount as 2 times 2000, that is the amount, or 4000, because it must be doubled, right? So here what happens is, to remove this coefficient, you divide both the sides by 2000, this cancels. So you're remaining only with 2 over here, and then you just solve it up. It'll take 24.75 years of investment to double this amount for this particular rate of interest, because the rate of interest is very low here, 2.8%. Yeah. Over time, the amount of carbon 14 present in non-living organic material decreases. Radiocarbon dating is a technique that measures the amount of carbon 14 that is present in these material to estimate age. The exponential function y is equal to ae to the power kt represents the relationship between the current amount of y of carbon 14 in organic material and the initial amount a of carbon 14 over the time t with the rate of decay k. Now, what we need to do is, they have given all the data, the amount of time it takes the amount of carbon 14 present in an organic material to decrease by half is given over here, 5,730 years. This is called the half-life. Use this information to find the rate of decay. Write your answer as an exact value. So now, this is the formula. I'll just write it over here. Y is equal to ae to the power kt. And they want you to find the k, the rate of constant, the decay constant, because as time goes on, this radioactivity of the carbon, it decays, right? That is given over here, the half-life, that is 5,730 years. So the time is known. Let's substitute one by one. Now, if I have the initial amount of, say, 1, like if I have a initial amount, what is the, after 5,730 years, what will be the amount? It'll be half of this, isn't it? Because it occurs a decay, half-life. So here y will be half of a. So I can write this as a by 2. This will be a. And what is e? E is a constant. K is unknown value. That is what we are solving, the rate decay. And the time over here given is 5730. Now this a and a cancels when you divide both the sides by a. So you'll have half equals e to the power k 5730. Now you take ln on both the sides, it will be half over here, and ln over here. What happens? I'll just write it directly. This goes because they're inverse of each other. You will have k times 5730, and now divide both the sides by 5730. That'll be ln half. This is n half divided by 5730 is equal to k. This is the exact value. I guess they want the exact value, so this is how we can write, I guess. Yes, that is what they want. Now, just bear in mind that is half, which I've written very weirdly. This is 1 divided by 2, divided by 5730. That's how we do the first part. Let's see the second part. Suppose a fossil initially contained 200 milligrams of carbon 14. Write an equation to represent the relationship between the age of the fossil and the amount of carbon 14 currently in the sample. Now, initially, some fossil which had 200 milligrams. Now we know all the other data. I'll write E, and the K value is known, ln half divided by 5730. Now they want the relationship between the time and the amount after certain time t. So here y, if I write, and this is the time, this is the formula. Let's just check, because they have not given any time, so it's with respect to time and y over here. So at any time we can easily find it out. Now if they tell you, say, okay, they have not given time, but they have told you use a graphing calculator to estimate how long it will take for the fossil to contain 40% or less of the carbon 14 it initially contained. Then solve the inequality algebraically and compare your results. Now here they are asking, for this one, what if it is 40% less, because it's a decay, right? Now this y turns out to be 40% less. It will be 40% of 200. So this cancels. Or you can just write over here 40% and over here 1. That's fine, because this always cancels off. Now you need to find what time, isn't it? Basically, how long by graphing, but I'll and compare your results. Okay, I'll just do it by algebraic method. Over here, it'll be 40% equals e to the power ln half by 5730 times t. Take natural logarithm on both the sides, and you're remaining with this entire term down. Okay, so it'll be ln 40% is equal to ln half divided by 5730 times t. And you can just solve this, take this to the other side and put in the calculator, you will get the answer. So here, that is what is done. But I forgot to tell you one important thing. 40% or less, this is an inequality. I took it as equal to. I'm sorry for that. I'll correct it now. Here they have told the fossil contains 40% or less. So it can be either 40% or less than that. So this, whatever answer we get, must be lesser than 40%. So it'd be greater than or equal to. If it was greater, at most more than certain amount, it'll be over here other sign. We are looking at this sign. Here this must be less than or equal to 40%. Okay. So this can be, lesser than that. So that's how we write the inequality. And then now when we solve this, I'll just solve it up over here. It is very important to solve it by parts. Don't just put everything in the calculator because it's inequality. If it was equation, it's fine. Directly put in the calculator, you get the answer. So let me just first to the left side, ln 40%. How much is it? It is, I'll write it out over here, negative 0.916 and 3 it will be. It's greater than or equal to. Now the same thing to the right side. Over here we have ln half, that is 0.5, or you can write 1 by 2 divided by 5730, and the answer over here is a very minute answer, that is, I'll just write it as it is, negative 1.209, it'll be 1, it's fine, into 10 power minus 4 time t. Now here, since we have both negative signs, what happens? The inequality needs to be changed, isn't it, when we are dealing with inequalities? Here, to make them positive, 1209 into 10 power minus 4t, the inequality flips. Now just divide here in the calculator. Now this must be positive, so I'll just multiply with minus 1. So now I can directly use this as the answer, 0.9163 divided by the answer, it's already saved. So the answer is 7574.72. So let me write it out over here, 7574.7. Now time must be more than or equal to 7,574 years. Only then it will decay more than 40%. It will be 40% or less. Otherwise, no. So see, it's little common sense as well. You have to have the value more than 40% or less. It should be decaying more, isn't it? So the time must be obviously more than certain amount. So that's one way you can understand this. Let's just say the answer. It's 7575 because it's zero point 0.7, right? So they have just rounded it off. Even in the graphing calculator, if you graph them up, you will get the same answer. Now, investment problem, we have done it a while ago, but here they have just told, I'll just show you over here. They have given you two equations. See, the same formula, 5,000 is invested at 2% rate of interest at time. And over here they have told one more, 3,000 invested, 4% rate of interest. And time is multiplied here. When will be the time when these both amounts are equal? What time? So you just equate this and this. Equate them and solve it up. Since it's an equation, you don't have to worry about anything. Just divide it however you want. You can put in the calculator, solve it up. The time is 25.5. Once you solve it till over here, you can directly put everything in the calculator and simplify, So that's the thing. If you want, you also can do one more thing. That is, just divide this 5 by 3. It's over, right? Now you can take ln on both the sides and simplify as well. But then over here, the property of ln must be used. So it's a bit tricky. No, anyways. So Try some methods, and it's up to you to solve it. If you use over here ln on both the sides, remember two terms are multiplied, so you have to do ln 5 by 3 plus ln e to the power 0.02 and simplify. But whichever method is easy, just follow that and solve it up. That's the end of this topic. It's about inequalities. Just be careful when there are inequalities. Remember, the inequality changes when there's negative and all that. Some basic things you must remember, and then it's all easy.